Hey everyone, in today's lesson, we're going to dive a little bit deeper into our data paradigm where we've learned how we can create a task, we can get input from a user, and we can save that. We learned that in the last lesson. We can save it to like a text file or to an Excel sheet. And in this lesson, more specifically, we're going to go over how we're going to import the data from that text file or from that Excel sheet. We're going to focus mainly on Excel sheet for this section of the lesson. You can go back to the previous lesson where we did input output if you want to focus more on that input of text files. And we're going to clean our data. So in case we're missing some data points, if we have some skewed data that doesn't really belong for the category of data we have, we're going to look at the data. That's very important. And we're going to create some kind of visualization, such as like a plot, maybe put a couple of overlays for like basic statistics, which we'll get into a little bit more next week. So to get started, I already have a data file that should be in the GitHub. And this is just a simple Excel sheet. And I've put some values in here. So we have our headers on the top. And so this would be like our ID. We have like the trial number that was run for that ID. These are completely arbitrary data points. Responses could be like the keys that were pressed during that trial, or where the mouse was at the beginning of the trial. It could be the X and Y coordinates. We could interpret this however we wanted based on the actual game. We would know what that would be. And then maybe the value, we'll treat that as like a timestamp. Okay, so I have this saved as data.xlsx, which is the standard Excel format. So in order to read from this, the first thing I'm going to use, if we're ever importing an Excel sheet, it's much easier to use pandas as our import method because pandas will automatically extract those titles that we had at the top of our Excel sheet. So I'm going to say import pandas as PD. And in order to read it, I'm just going to say data frame or DF, which is the name of the data frame I'm reading in, PD for pandas, read underscore Excel, and we're going to open that file name, so data.xlsx, close our parentheses, okay, and I ran a little bit too early, so we're going to go ahead and come down here, and let's say we're going to go ahead and pull some data out of that. So we're reading it into that data frame, and let's go ahead and get all of the IDs of that data frame. So the IDs are that first column, if you remember down to my data that I had here. So the ID column are all of these P numbers here. So we'll create a variable named IDs, and we'll query that from data frame and search the ID column. Capitalization does matter here. So because my title is ID, there's no extra spaces or anything, I have to spell it exactly the same or it will not match. Okay, and then let's go ahead and get responses. Say that's the next thing I want. We'll say data frame and then check exactly responses, and then we'll double check with our actual data just to make sure. Okay, so in this case it says response and I typed responses, so let's erase that S there so that it matches up perfectly. And then when we're done, we'll go ahead and print data frame dot head. This is going to give us the top 5 rows of our data frame. This is just a quick way to just visualize your data. I highly recommend doing this anytime you import data, just to make sure you type the right file name in, or you're pulling the right data, you're pulling everything you need. You might be missing a column, or there could be something wrong with your data and it's just not there. So when we print this data frame head, this is just going to give us a snippet of the top 5 lines of our data so that we can verify that we're importing the right thing. Okay, so I'm going to go ahead and hit save, and I'm going to go to run. And right now it's going to give me an error because I typed red Excel. Okay, let's go ahead and save that. And I probably will still get an error because there is a dependency that the pandas library needs for reading Excel that I don't think I have. Okay, so there is another library that reads and writes from Excel sheets, and it's called OpenPyXL. So Open Python Excel kind of makes sense. So in order to get this to run, even though we have the pandas dictionary, we don't have all of the dependencies that it relies on. So all of those other libraries that pandas is built on. So we're going to come in here and we can do conda install open PyXL. And if that works, then you will be done. If that doesn't work, then you can try that with the conda install conda forge, or you can try it with the pip install directly. And if that doesn't work, then we'll have to troubleshoot that with a quick Google search. But that should install it for you. And when it's done, it'll say the collecting package metadata. And we'll give it just a second. And then it should be finished. We're going to go ahead and hit yes. We want it to install now that it has downloaded. And it extracts, and then now it should be good to go. So I'm going to go ahead and clear my terminal. So I have a nice clean terminal down there, and I'm going to hit run again. And this time it should run. It is importing this Excel sheet that I have here. And as you can see, it's displaying the first 5 lines there, indexing at 0 for each of the rows of the data. And it has already pulled all of the column names, so we know we're reading the correct data. So that is how we parse the data. And when we say parse, we're simply meaning go through the text file, go through some data file, and read that data into our program. And we're going to organize that data some way. The good thing about using pandas is it organizes it for you automatically if it's already saved in that text format. So if in the previous lesson when you were doing your task, if you use the pandas data frame to save your data, then importing it back into your code is going to be so much easier to do that secondary processing. Now, if you did save it as a text file, it's not that tricky. You're just going to read it back in like we did in that first lesson, and you're going to have to do a couple of for loops in order to get through everything within it and then put all of that information into a dictionary or an additional list, or you can put it all into a pandas data frame from there if you'd like. Okay, so the next thing that we're going to go over is cleaning our data. So if you notice in the example that I gave you, right here under the response for P002 and trial 4, I purposely left an entry blank. So this is like if we sometimes miss a data point, or if you have some kind of timeout in your task and maybe it just doesn't save the data, or maybe there's a glitch in the game and you just lose one point of the data. You don't want to lose and compromise your entire data set, or maybe you have a purposeful timeout, so if they don't respond in a certain amount of time, you just skip it, and then you would not have a response for this one. So it might not always be a glitch, it could be intentional, but regardless, we don't want to lose all of our data just because we have this one trial that's bad. We can still use all the rest of the trials. So one way to get around this is when we have our data frame that we have entered into our code, we can clean the data frame. So I'm going to say data frame clean. So I'm going to create a new data frame and just take the old data frame that we have, and I'm going to clean it up with a drop NA. So that NA is that missing value. It's a NaN value. So I'm going to say drop NA, df dot drop NA. Open close parentheses. So this df is the data frame that we read in originally. We're going to drop the NA values, and we're going to rename it, that dropped clean version, to be df clean. So I'm going to come here and I'm going to print df underscore clean. So we'll comment this one out, and we'll save and go ahead and run. So as you can see, we no longer have that trial 4 here that we had before. And it also went ahead and removed this trial 5 as well, because if you notice, we have a missing value under the value column. These other ones are still there. We're still going to have to fix that invalid in a minute, but we have dropped all NAs. Now, let's say sometimes we don't want to just drop the entire row. We just knew that purposely we didn't want to save an entry because it timed out, or we don't know what they pressed because the trial went to the next trial before we could register that key press, or who knows what happened. But we don't want to lose the rest of the data in that column because we still do have like that XY coordinate. Maybe that's important, so we don't want to drop that entire row. And the way we can do that is we can, instead of drop NA, we can fill NA. So let's go here. We're going to do df filled, or I can say fixed. if we wanted to. And then we're going to say df.fill NA, and then we're going to tell it what we want to fill. So we're going to open a curly bracket, and we're going to say in the response column, we're going to put unknown. Okay, so for any of those NAs that are in the response column, we're going to fill it with the word unknown. Okay, so now I'm going to come here, print data frame fixed. Okay, and we're going to close that one out. Clean up a little bit. Okay, so now let's go ahead and run. And as you can see, we have that trial 4, and we filled in the word unknown where there was that gap in our data right here. Okay, and then we still have that NaN standing right there in this other portion because we haven't filtered that one out yet. We only told it to fill in the response column, any blanks in the response column with unknown. We could do the same thing for that value column if we wanted to, but we're not going to do that for now. Okay, so another thing that we notice is sometimes we might not just be missing data that we need to remove. We might not need to replace that missing data. Sometimes we need to make sure the data is of the right type. So we might have data in the table, but it might not make sense that that data is there. This is why we always want to look at our data first. And in this case, we have something that says like invalid. Okay, well, let's focus on this one. Can we have a negative trial number? Well, depending on how your game was set up, I guess that's possible. But in this case, typically a trial is not going to be in the negative. So we're going to set a restriction and say that everything in this column is supposed to be a positive integer. And if it's not, we need to do something with it. So we're going to come here and we will create a new data frame that is filtered. So df underscore filtered. So filtered for invalid data. And we're going to take that original data frame that we read in, and we're going to take a subset of that. So we're going to say data frame, search for that value column here. Okay, so if we look in here, we have like that value column right here. We want to make sure they're all greater than 1. Now we could change this if we didn't want value. Let's actually go ahead and do trial number. Okay, and then we're going to do, we're only going to add it, the data frame, we're only going to pull the trial number if it is greater than or equal to 0 in that value column. Okay, and I have an extra square bracket here. Make sure your square brackets line up. So we're querying the data frame for all of the rows that have trial greater than or equal to 0. All right, and now we can come here and we can say print data frame filtered. Make sure we got rid of all of our other print statements. I'm going to come down here and clear this out so it's a little easier to see, and we can pull this up a little bit so we can see more. Okay, and we're going to run that. And as you can see, that trial -1 has been removed. All right, so we can do a combination of all of these. So instead of just querying that data frame every time, we could filter it. And then after we filter it, maybe we still want to remove that NaN value or replace that NaN value. We could take this and put it below, and then instead of data frame, we would use that data frame filtered to be able to put here. And then that would first filter out all of the -1s, the invalid data type rows, and then we could go ahead and we can fix and fill those NAs for the other rows, and then maybe we can drop the rows that have a value that's empty in the other one. So we can do a combination of any of these. You would just do them line by line and make sure if you rename them, then you use that new name every time you're going to do a secondary cleaning of your data. But in general, that's how we clean our data. And now we have that data. This is our data frame that we can see here, and we can start doing stuff with the data and inspecting it a little bit further. So the next thing that we want is to do some like simple statistics. We'll get more into statistics next week, just a general overview. But if we have statistics, sometimes this can tell us some basic metrics that we might need to determine what kind of graph we want to display. So if we have a data set that looks like this, and we let's say it's longer than just 10 entries long, it's like 1,000 entries long, and we want to know what is the x-axis range if we're just going to create a plot. What do we need that x-axis range to be? Or are all of these numbers really, really close together, and maybe it wouldn't be beneficial to do like a scatter plot? Maybe instead of using a scatter plot where you just put a whole bunch of dots on there for all of the values and try to see a trend, maybe they're really, really close together and we need to get something that's a little more descriptive of our data. Maybe we're not going to be using the XY coordinates. Maybe we could to do a line plot, maybe we could do a histogram plot of when they were at a specific X or Y coordinate, or how many times they pressed a key versus another key, or when the value is over a certain threshold. So there's a lot of different things that we can do with this. And what we're going to do for right now is we're just going to take one of these columns. So we'll just take the value column, for example, and we can calculate some things with this value column. So I'm going to comment this out here, and we're going to come down here. I'm going to go ahead and just comment all of these out as well, because we don't need to filter out any of it. We're just going to use the raw data frame from the Excel sheet with the nans. Okay, so first we will use Matplotlib. So we have pandas already imported, so we're going to import matplotlib.pyplot as PLT, so we don't have to type that over and over again. And we're going to come down here and let's just do a simple calculation. So let's just say average value equals data frame that we imported, the value column. Okay, so we're going to search all the value column and we're going to do mean, MEAN, open close parentheses. So this is just going to access all the values in that value column, make sure those are numbers. So we have them all and they're all numbers here. We may have to do a replacement in a minute. Okay, and then we're going to just print the average. So average value. Okay, and then let's go ahead and run. And when we do this run, it's going to ignore that NaN value and we get an average of 1.79. Now we can look at these numbers, and if you wanted to double check, I would not suggest working in the Excel sheet as you're working with it in Python. So I'm just going to do it for purposes of today. Typically, you want to have your data sheet closed when you're accessing it. Excel is very picky about temporary files. When you have the Excel sheet open, you are not allowed to save to that Excel sheet or add anything to the Excel sheet. It will crash and crash your entire program. So you have to make sure you close out of that Excel sheet on your computer and make sure it's not open anywhere else if you use like a cloud storage device, because if you do, it will not save and you will lose all of your data that you're trying to add to that Excel sheet. So just good practice, close the Excel sheet before you run your code. But for today, we're not doing any writing, so we're going to keep it open. So I'm going to come here and I'm going to type in a basic Excel command, average, and I'm just going to select all of this here. And you can see it says 1.8, but it's because our decimals are a little higher. So if I kept going all the way down, then eventually it would give us this 1.7999998. So I'm not going to force Excel. So Python is already a little bit better at calculating an average than Excel. And now we're going to come back over here. So we've created an average, and that can give us a little bit of information about this. So maybe with this, we do want to do a scatter plot because we have a mean. So we want to see how maybe things are around the mean. So we can come down here and we're going to say plt.scatter for scatter plot, if you remember from the library lesson. And I'm going to do df, and I'm going to type index as the one index that we're going to plot. So we come back to our data and you can see our index that we have. That should be ID, not index. So I changed it up a little bit. Okay. So we're going to say our ID is going to be what's across here. And then for our next one, we're going to have data frame value. So that value that we just took an average of is going to be our y-axis that we have. And let's just do color equals purple. Okay, make sure we close those parentheses. We need to add a couple of elements to our graph. So let's do plot.title, and then we'll say value by ID, plot X label. So this is not label. This is just the label that's going to go across our x-axis, and then we'll put the IDs are going across the x-axis, and then we'll do plot Y label, and we'll call that the value. So that's what's going on that y-axis there. We can set it as a plot.grid. This is just a way, so you can see it's just a different way of plotting. We're going to set it like this. If you want to know a little bit more, there's a lot of documentation within Matplotlib. And I did not mean, nope, let's go ahead and kill that terminal. If you hit Shift and Enter, it will try to run for you. So just don't do that. Okay. And then we're going to come here and we're going to say plt.show, open, close parentheses. Okay. And then we're going to go ahead and run this. Okay, so we got our average here, and now you can see we have these purple dots that were displayed on the screen, and this is just showing for each of the IDs what was their value. Now we can add some other really cool things where we can add a line on top of that, and we can not just see our data, but maybe we want to see our data and we want to have some statistics on top of that so that it's ready for publication, or it's ready to be able to show somebody all of the information that we know about this data, and they can just look at our graph and quickly understand what the data is showing us. So that's what we're gonna move into next. In order to do this, we're gonna scroll down a little bit. We have that scatter plot that we already created. We can make this scatter plot a little bit fancier if we wanted to, but and I have an example set in the lesson summary. We can do that one in just a second if you'd like. But we're going to just come here, and we've already got the average value that we calculated for the value set. So we're going to create a plt.axhline. So H line is a horizontal line. If it was AXV line, then that would be a vertical line. So remember, horizontal is like the horizon where the sun comes up, it's left, right, and vertical is up to down. Okay, top to bottom. Okay, so we're going to come here and we're going to say y equals, so the y value that we want this horizontal line to be at is going to be our average value, that thing that we calculated here. So that's where we're going to draw the line across the graph here. And let's say color equals, I guess we could do teal. Teal is a good color. Okay. And if we wanted it to just be like a single solid line, we could just leave it as a single dash line, or we could change that line style. There's a lot of different options that, make sure I spell that right. If you look at a documentation for Matplotlib, each of these functions, so like scatter plot, AX line, so you can kind of hover it and it'll show you most of them. AX line, they have these specific parameters that you feed in, and all you have to do is type what you want. So if you want the line style to be dashed, or if you want the line style to be, or if you want the scatter plot to have squares instead of circles, or you want open circles, or you want triangles or stars, or whatever other text you want. You could have a bunch of A's on the screen if you wanted to. You can set that as a custom parameter within that plotting function. So then we're also going to give it a label, and this is going to help us for putting it in our legend at the end. So if we want somebody to be able to quickly look at our graph and we have multiple data over top of each other on that graph, we need that legend in the corner so people can quickly know which lines, like is the dash line or is the purple line or the the teal line, which is which. And instead of having to manually put that on top, we can do that directly through Matplotlib by assigning it a label as we plot the line. So as we plot that scatter plot, we could give it the data set, each data set a different label, or we could give this horizontal line a different label. So when we create that legend, it will automatically show up for us. So let's do an F literal string, and we're going to say average, and then we'll put that average so it's like actually written out and it's not just estimated based on how high it is on the graph. And we'll do that, the inline literal, and we'll say average value. And we're going to give it a little bit of a different format. So if you remember when we printed that average value, it was 1.799999. We don't want to display that on our graph, so we're going to force it to only have 2 decimal places. So we'll do .2f after that colon. So it's saying use the average value, but because it's a float, we're going to round it to 2 decimal places here. Okay, and then we close that out, and that should all be good. And now let me close this so we have a little bit more room. Okay, and then the next thing that we're going to do, so we already have our title, we have our X and our Y labels, and we're going to add a legend. So plt.legend, and given that we've already given a label up here, it should automatically find that legend for us. And whenever you're putting a legend on your graph, it's a good idea to do plt. We want to do this after we create the grid. So any formatting you do to the plot, you want to do this tight layout, plt.tight layout, open close parentheses, to kind of pack everything together and make sure that you don't have the legend clipping off the side of your graph. So if you go to save it as a figure and your legend is off to the right, then you're not going to be able to just resize it. It's just going to cut it off. It'll crop it off and you won't be able to see it. And we'll save the figure in just a minute. So for right now, we're just going to go ahead and show so you can see what it looks like. And make sure you have closed out of your previous run or else it will not work. Okay, and then now it should run and it will pop it up. And as you can see, this is our average value. And this guy's actually right there on the average value. And it shows us our legend on our graph. It will find the proper placement for it automatically, or you can force place it in a specific location. You can force it to be outside of your graph or in the bottom right or wherever you'd like on your graph. Once you see it here, you could just hit save, and you can save it manually like I talked about when we did the libraries lesson, or we can come in here and before we show our plot, we can say plot.save fig, there we go, and give it a name of what you want it to save. So we'll say my cool plot.png. And if we want to make sure that it's a high res, especially if you're going to be uploading this into a paper, you don't want it to be that little tiny thing that looks like it's been screenshotted. You want to make sure your DPI is 300 or higher. 600 is a very large file, so I would recommend just sticking with 300. And unless you're putting it on a poster, 300 should be fine. For a poster, I would probably go around 600 DPI, and that's the densities of pixels. So it's how many pixels do you have per inch. So I think it's density of pixels per inch for DPI, if I'm not mistaken. Okay, so we're going to do that, and then this is just going to save it directly to the file we're working in. So when I run this, it's still going to show the plot, but it should have already saved that plot as well. So if I come over here and I click on it, then my plot has now been saved to my computer, and I can send that and do whatever I want with that. And you can do some further editing for your font style and your size and all of these other things from there. But that's getting into the nitpicky of the graph. But essentially, we have an advanced plot. We've added items to our plot, and we're pretty much ready for putting it in a paper or putting it on a poster or just showing it to somebody else. And we have all of the elements we need. We could put a figure legend at the or a figure caption at the bottom as well with just regular text. You can type that in, and that would just be added in the same as we would with all of these titles and labels and everything. Or you could do that in the post processing phase. So the last thing that we're going to go over is a little bit of a fancier plot, and you won't use these as often, but they sometimes can be helpful, especially if you're dealing with non-two-dimensional data sets. So in the case of our graphs that we have so far, we just have that x-axis and the y-axis. We're just plotting two things at once. But let's say that we want to plot that value and that ID that we have here, but we want to sort it by like the response that they had. So we go back to our data here. So we have this ID and we plotted this value, but let's say we want to sort by the key that they pressed. So maybe the key that they pressed has some impact on the value, and we want to see, is there a correlation without doing full statistics. We just want to visually see if there is something, and then we could overlay a statistics on top of that. And the way that we're going to do this is using we could do a type of three-dimensional plot or a color coordination plot in Matplotlib, but there's another library that I like to use when we get a little bit higher dimension, and that's called Plotly. So we're going to import plotly.express. We're just going to use a smaller version of it as px. Okay, so I'm going to come all the way down here, and all that we have here, we're just going to go ahead and comment that out because we don't need to be using this. We still need to import our data, but as you can see, we don't have it installed. So let's just try conda install plotly. Spell it correctly. And if conda install does not work, then we could always try pip. We could try conda forge. There's all of the different packages. Whatever works for you, typically with one package will work with the rest of the package on that specific interpreter. So we're going to let this run. So while this is running, we're going to go ahead and type some of that code out because we're not going to run quite yet. So we are going to have what's called an interactive scatter plot. So we have that scatter plot where we show the, make sure to hit the Y when it's installing. We have that scatter plot where we saw that X and that Y, but sometimes if it's 3 dimensions, we want to be able to like hover over it, zoom into certain things. And there also are some 3-dimensional plots that we can kind of rotate and see from different angles as well. So we're just going to do a simple interactive scatter plot for today's purposes. We're going to say figure equals px dot scatter. So very similar to when we are creating this like dot scatter here, but we're going to assign it a name so we can do some stuff to it in a minute. And we're going to give it that data. So df was our data frame. And we're going to say our x value is ID because that's what we have in our data set. So always double check your data set and see what the name of that label is. All right, and then we're going to have our y data set is going to be the value column. So anything that's in this value column here is going to be what we're going to plot on the y. And then we're going to have a color hue. So we're going to color coordinate it by response. So based on what key they pressed will determine what color it shows up. Okay, so I'm going to go ahead and put a comma. You can hit enter here if you're running out of space on the line, and it will automatically tab over and keep it within that parentheses, and it should not give you an error. All right, so title equals, we'll say value by ID with, we'll just keep it value by ID because it's kind of the same thing as before. All right, and then we'll do labels. So in this case, we're going to manually tell it the labels that we have. So we're going to have index or ID, since we're using ID, and then ID is going to be, okay, we'll just keep it all ID so that we know that the ID is what's going to go in the legend as that specific ID. So it's going to pull and see what that ID value is for index. And then that's our X. And then for our value, we're going to do the same thing. So our values are going to be whatever our actual values are here. Okay. So this is just like we did before, where we gave it our label ID and value. We're just saying that this data column is going to have an ID label of ID and a value label of value for our X and our Y. Okay, so now we're going to come down here. We're going to use that figure we just created, and we're going to update the layout. We're going to show legend equals true. Make sure you spell that correctly. So it's just like this plot legend that we had in Matplotlib. Fig.write image. So this is exactly the same as we did for the save fig, but now we're going to write image. It's just a different way of saying the same thing, but doing it with Plotly instead of Matplotlib. And we're going to call this interactive plot instead. .png, just like we did before, instead of my cool plot. And you can also pass it some size parameters here, but we're not going to do that for this purposes. And then fig.show, just like we did plot.show before. Okay, so now that this is installed, we should be good. We should no longer see that error on that Plotly. And then we're going to run it. And when we run, okay, so I'm also missing this additional dependency, and it's called Kaleido. This is something that the Plotly package will use. So we're going to do the same thing. I'm going to do my conda install Kaleido. I think I spelled that right. Could be completely butchering the way that that's pronounced. Pretty sure it's like Kaleido or Caladium. Okay, and we'll let that run. And it should be asking us to confirm in just a minute. And it actually went ahead and finished. Okay, so I'm going to clear my terminal, come up here and run. Okay, let's try that one more time. And we're going to run. Give it a second. There we go. Okay, and then now we can see this is our Plotly plot, and we have this key over here. It should automatically open up in your browser. So we have the same thing that we saw before. We have all of these, but now they're color coded. So this, if we hover it, we're able to see that response. We can see all the data that's associated that we imported for this particular plot. So the ID, the value, and that response key. And hovering will give us that color. We even see that invalid that we had here, and there's just different colors. We can set a color scheme if we wanted the colors to be specific. We can zoom in to any of these. So let's say we have a lot of data here in this point. We'll double click to zoom back out, but we can now quickly analyze all of our data and see it. This isn't necessarily what you would use for a publication, but this is really good for personal use or when you're trying to work through your data and see if there's something that you might have missed that maybe you need to run a statistics test on to see if there's something in that data that could support your hypothesis. Okay, so when you're in here, you can do all of these different functions here. You can download it directly as an image, but because we've already done that, I'm going to close this out. If we come over here in our folder we're working in, we should have that interactive plot. And as you can see, it saves just a very generic version, which if we compare that back to the plot that we had with Matplotlib, it has a little bit of a different look to it, but it's essentially showing us the exact same data. All right, and that is pretty much it for today's lesson. There's a lot more you can dive into any of these topics. I would look at the documentation to see what other kind of plots you can use. The Plotly I usually would only recommend using if you have a lot of data and you really need to like zoom in and look at specific clusters of the data, or if you have a 3D plot and you want to have that interactability, or maybe you want to filter out, and there's a lot of additional steps that you can add into a Plotly. So it is a very useful tool, but if you're trying to create a plot just for a figure or for a poster, Matplotlib is usually the go-to for that. Okay, so hopefully you guys learned something, and we will start back up next week with the next lesson.